Well, what a big breakthrough China just made. China recently announced that its artificial sun has achieved a plasma current breakthrough of 1 million amperes. This is another breakthrough in the world after the 1056-second long-pulse high-parameter plasma operation. The new record of the device's nuclear fusion technology has brought China's nuclear fusion technology to the forefront of the world. Do you know what nuclear fusion is? Why is it called an artificial sun? Is China really on the verge of ultimate energy? Well, the basic principle of nuclear fusion is that when light nuclei are combined into heavier nuclei, huge energy is released. That is, deuterium and tritium react to form helium. This process can provide a large amount of energy. The sun also relies on nuclear fusion reactions to bring light and heat to the solar system. However, nuclear fusion requires very harsh reaction conditions, which has hindered human beings in their search for the ultimate energy source. At present, the level of nuclear fusion research is a reflection of the country's comprehensive technological strength. Extreme environments such as ultra-high current, ultra-strong magnetic field, ultra-high temperature, ultra-low temperature, and ultra-high vacuum pose new challenges to technological capabilities, and are also an important development direction for future science and technology. At present, Chinese equipment that has reached the international leading level will also achieve new breakthroughs in the operation time and energy gain of nuclear fusion in the future. Today, let's take a closer look at this ultimate human energy source and its development in China. Okay, let's get started. First, let's talk about what is an artificial sun. Well, its full name is the Superconducting Tokamak Nuclear Fusion Experimental Device, also known as EAST, which is an experimental device led by China and jointly established by Japan, India, South Korea, the United States and so on. So, why do we call it sun? Well, on the one hand, it is that the temperature of this experimental device is much higher than that of the center of the sun. The central temperature of the sun is 20 million degrees centigrade, but the experimental temperature of this device has reached 160 million degrees centigrade. In terms of temperature alone, it is not an exaggeration to call it an artificial sun. On the other hand, it is because the experiment uses the experimental method of nuclear fusion, which is exactly the same as the sun releases energy by nuclear fusion every day. So the artificial sun can be simply understood as a device for conducting nuclear fusion experiments on the ground. So, what would an artificial sun do? In fact, the artificial sun, like the current nuclear power plant, is solving the problem of human future energy. And the artificial sun program has been developed in the world for nearly 60 years. The reason why the experiment of nuclear fusion is so laborious is mainly because the energy generated by the artificial sun that performs nuclear fusion is the ultimate energy pursued by human beings. According to relevant statistics, according to the current human consumption of energy, it will not take too long, that is, in 200 or 300 years, the fossil energy on the Earth will almost be wiped out. If that time comes, what should human beings do? Waiting for human civilization to fall back? Of course the answer is no, and human beings will not sit still stupidly. The solution is to develop new energy sources. In fact, the nuclear power plant invented in the 1950s is a very good solution. In China, a 1 million kilowatt power station consumes about 1.5 to 2 million tons of coal a year and emits 4 million tons of carbon dioxide. In order to reduce global carbon dioxide emissions, China has made a solemn commitment to the world to achieve carbon neutrality by 2060. Obviously, this is a huge challenge, because so far China has not had a proper solution to carbon dioxide emissions. In comparison, nuclear power plants consume fewer resources and do not emit carbon dioxide. A nuclear power plant only needs to consume 30 tons of uranium a year to generate 1 million kilowatts of power. However, nuclear power plants also face two problems. First, their resources are not unlimited. According to the statistics of scientists, these uraniums will be used up in about 1,000 years. If technological progress increases the consumption of uranium, the time period will only be shorter. The second is a problem that everyone is more concerned about. Nuclear power plants will produce radiation that is harmful to the body. Scientists have not yet solved this problem well. Having said so much, you may understand that the current situation of human beings in terms of energy is that there are not many resources that can be exploited. Environmental pollution is serious, and energy development cannot keep up with human consumption of energy, so human beings urgently need an ultimate energy source to solve all the above problems. So, what is the ultimate energy for mankind? The ultimate answer is most of the fusion energy, with a small part of renewable energy. The fuel that supports the nuclear fusion reaction is deuterium, which is mainly obtained from the ocean, and deuterium is mainly in the form of heavy water, which does not produce any carbon dioxide. A common sense we have known since childhood is that the Earth is actually a water polo, and nearly 7/10 of the area is the ocean. If the fuel deuterium is extracted from the ocean, 1 liter of seawater can extract 0.034 grams of deuterium, which means that 1 liter of seawater can release the energy of 300 liters of gasoline, and there are resources in seawater that can be used for 10 billion years for human beings. What does this mean here? That is, its resources can provide almost endless energy for human beings without pollution. Therefore, the energy produced by nuclear fusion is the ultimate energy for mankind. As we mentioned just now, the experiment of nuclear fusion has been started since the last century, but until now, the technology of nuclear fusion power generation has not been mastered. Many people are puzzled. From the explosion of the atomic bomb to the emergence of nuclear power plants, it only took 5 or 6 years, and it will be realized soon. But more than 60 years have passed since the explosion of the hydrogen bomb, but the nuclear fusion power generation of the hydrogen bomb has not been realized. This is not to say that the scientists who do fusion do not work hard, but this thing is too difficult. Creating a sun is not something that can be achieved with just 2 or 3 sentences. So, what are the main difficulties of nuclear fusion? In order to achieve nuclear fusion power generation, the most difficult thing is not the device that can realize ultra-high temperature experiments. The two main difficulties are how to realize the ignition of hundreds of millions of degrees, and how to carry out stable and long-term constraint control. This time, China achieved a plasma operation of 120 million degrees centigrade for 101 seconds, breaking the record held by South Korea at 100 million degrees centigrade and for 20 seconds, and extending the record by as much as 5 times. It can be seen that China's research in nuclear fusion experiments has reached the world's leading position. All in all, the creation of this new record once again proves the feasibility of nuclear fusion energy. So, have you heard of China's artificial sun before? Do you have any other ideas about nuclear fusion technology? What applications do you think it can have in the future? Well, please leave your ideas in the comment area. Looking forward to your reply. Thank you so much for your continuous support. Your precious time with us is highly appreciated. See you.